Hello everyone, welcome back. Recently I started working on an IV generator, a geometry node setup. It's quite nice to use and I thought I'd share some insights on how to set up a system like that so that sticks to the wall and branches a little bit, spawns some nice leaves, stuff like that. So we're gonna do a tutorial on a simplified version, okay? So let's get started. Now, whenever you wanna branch something and have something, well, drown for example, you're gonna start off with a curve. And to do that, we're gonna delete our cube. We're gonna hit Shift A, curve, and Bezier. And I'm also gonna hit Shift A, mesh plane. Right, so this is gonna be our Y90. This is gonna be our, well, plane we're gonna stick it to. So right away, I'm gonna turn on my screencast. Here we go. Beautiful. And this curve, I'm gonna just go in edit mode and delete all my points. And then I'm just gonna draw a preview curve, a placeholder, just like this. Beautiful. So this is gonna be our IV starting point. So I'm gonna open up a window, go to geometry nodes, hit new, and we're gonna get started. It's amazing. So first things first is we need to have sub-branching. Okay, we can't have only one strand. We need to do like 2 or maybe even 3. So I'm going to do that by just dragging this out to our resample curve. Remember, if we are going to stick with the original curve, we're going to have, well, 3 points or 4 maybe, because it has curve handles. But when we resample it, we're actually going to get all of those segments and sub-curve points, right? So that's gonna be useful for scattering new points. So I'm gonna delete my viewer, and we're gonna right away add a join geometry node. There we go. And let's move this to the right and let's reconnect our resample curve, even though we're not gonna need the actual curve. Now on this resample curve, I want some extra instances, right? Some extra curves. So let's add an instance on points. And the instance is going to be drag it out to a curve line. Amazing. So let's just fix that rotation right away. So to do that, I am going to hit Shift A and find a curve tangent. And the curve tangent is, remember, the direction of the curve. And we want this to be aligned to not the direction of the curve, but the normals on the direction. So to do that, we're going to drag this out to align Euler to vector. And the tangent is going to be the vector. And the direction is going to be Y. And the rotation is going to be the rotation. Right, so now it's nicely aligned into the normals of the curve. Now, I want to have a little bit more randomness. Right now everything is to one side and I want to switch that off a little bit. So to do that, we're going to hit Shift A and find a rotate Euler. And that allows us to rotate this rotation output. So drag that in there. And I'm going to rotate it with an axis angle. The axis is going to be the tangent, right? We want to rotate around that little curve itself. And the x is going to be the tangent, is what I just explained, and the angle is going to be 180 degrees. There we go. Now if we connect this one, we can see that the rotation is flipped. I want that for some of them. So I'm going to just drag all of this to the left just a little bit, disconnect this rotation, Shift A, find a switch, and set this to be vector. And we want the input switch to be a random value, right? That's going to be a Boolean value, which means that there's a probability for when the switch is true and when it's false. And the false one is going to be the normal one, and the rotation is going to be the rotated one, and the output is connected to the rotation once again. So now you can see we got a little bit of randomness of when the curve is in which direction. You can change that with the seed, of course, quite easily. Beautiful. That's a nice starting point. I'm going to leave this at 0.5 because it was half of them. I want it to be in the one direction and the other half to be in the other one. Beautiful. Now we want to, let's see, have a little bit more random rotation, I guess. Right, so let's hit Shift A and find a rotate Euler once again. Here we go. And I want a little bit of a random rotation in the axis angle. And then axis angle is going to be the, let's say, normal direction probably. So this is the normal direction, so drag that in there. And we're going to hit random value on that rotation from like, let's see, -2 to 0, right? I want it to be aligned just slightly to that normal Something like this, perhaps. Right, let's see what happens when we continue this process. Okay, so some of them are just angled up more and some are angled down a bit more. Let's actually set this value a little bit higher. There we go. It can be positive too. Beautiful. Alright, so those are some spawned instances. Amazing. Now I want to give that a little bit of noise, of course. So let's hit Shift A and start off by realizing our instance. And then hit Shift A and set position. Beautiful. And the offset is going to be a noise texture. And we want the color. And for the vector, we don't really need to change that, but we have a vector input and a color output, and it's gonna offset our actual vector by 0.5 like this. And that means that we just have to reset it back to 0 with Shift A, vector math, set to subtract, and 0.5, right? It's back to 0. Now, we don't really have geometry to offset, right? We don't have that. We have just got a curve line as an input, which has 2 points. So we need to hit Shift A and find a resample curve. And we're going to set this to, well, 10 is fine for now, I guess. And I'm going to duplicate my subtract nodes and set this to scale. And I'm going to set the scale value to be dependent on the curve, right? So the start points of the curve where they come out of our original curve, those points shouldn't really move with the noise texture because then they will be detached from the original curve. But the endpoints can do whatever they want, right? Scribble away. So I'm going to set my scale value to be the spline parameter. And that way the start points are 0, so scaled with 0, and the endpoints are scaled with 1. Beautiful. So we can just change all of these values if we'd like, the scale, stuff like that. And we can make it less strong and stronger. Amazing. Now, what I want to do next is let's just make sure that we have some nice strength going on. So we can just discover the issue we're having is that some of these points are going through the mesh, right? And that's not something we want. So we want this to be going into only the normal direction. So how do we do that? Well, we need to compare our curve's position, right? And that's going to be the output of the noise texture right here. We want to compare that to the normal direction of our plane. And if it is in the negative normal direction, we want the noise to be flipped into the positive one. So we're going to set that up. And that's going to be, well, mediocre easy, I guess. It's not going to be hard. It's not going to be easy. So let's hit Shift A. And first things first, we need to grab our plane as an input, and we can also just drag that in. So the plane, the object, the emitter object, we can set that up later. This is going to be the object that's going to define that normal direction, right? So we need to get the normals from this plane as information on the curve. So how do we do that? Well, we need to transfer the attribute, nowadays called sample attribute, right? So find sample index and Shift A sample nearest. Those are the two nodes you usually need. And the index is going into the index, the geometry is going in the geometry, and there as well. And then we want to sample a vector, and the value is going to be the normal direction of that plane. Right? So the output of this sample index, once we connect that to something related to the curve, is now going to be the normal. All right, so now we can actually use that value to compare these two. All right, so let's hit Shift A and find a compare. And let's set this to be a vector, right? And this vector is going to be, well, comparing vector A and vector B. And I want this to be set at the direction, right? Because now we actually have an angle we can set. And the result is going to be, well, 1 or a 0 value, right? So when our normal is going to be in the negative, we want that switch to flip the direction, which means that we need to also flip our noise texture before we can actually flip it. So let's drag that out to a vector math, and let's set this to be reflect. Quite easy, right? So now this is going to reflect, and the direction, right, the second vector, so what I want to reflect it in, is going to be that normal, of course, that normal direction, right? So connect that in the bottom there. And now we have two vectors, right? One of the normal noise and one in the reflected noise. So we can control that with a switch node. So find a switch, set this to be a vector, The input is going to be the result here. And then we have our normal vector. So this one goes into false. And if this is true, we're going to reflect that value. There we go. Let's make some room and connect this to be the offset. Right, so now that it's connected, it's still not working. Reason why is because our plane is set on original and it needs to be set on relative. Now we got the wrong direction. So what we can do is just set this to be greater than, and we got it beautifully working, right? So everything is now moving to the normal direction of the plane. And this means that even if you add it to a circular object or a house, whatever, it is going to be moving this away from your surface, right? In the normal direction. Beautiful. Right, so this is quite a nice starting point, right? So what I'm going to do is add just another set of branches just because I want those ivy leaves to be spawned on smaller segments. So we're going to do that, right? So we're going to drag this out, the output of our second curves, to, let's say, another resample curve. So we can define how many of those third layer curves we want. And then we can use this to add more instance on points. And the instance is going to be once again a curved line. All right. And let's just connect this back up too. Amazing. Nice. So we can set the resample to be like 5, perhaps to add a little bit less. And then we can get started once again. So we want some random rotation once again, but this time I'm not really going to use the same kind of setup, I think. Simply because last time we just wanted them to go up or down according to the normals. This time we can rotate it more really around that Z direction, right? So to do that, I'm going to set up the rotation. And first things first, we need a curved tangent, of course, right? And we need to add an align Euler to vector. Vector being our y direction with a vector in the vector. Beautiful. All right, so now it's going into that direction, but some of them are still going to the inside, right? Which is not really what we want to have happen again. All right, this time to prevent those lines from going into our object, we're actually going to compare the rotation of this Euler to the rotation of the normals. Now we don't have a rotation yet because the normals are a vector, right? So we have to do the same thing. So we already have, let's see, our little setup here that controls or gives us the normal input. So I'm just going to duplicate that for now, right? There we go. And this value I want to turn into a rotation so we can compare that. So how do we do that? Well, let's find an align Euler to vector, right? And we can use the x direction. We can also set this to x perhaps. Let's keep that to y. And then we can compare the two of them, right? So let's set this to be vector. And then I'm going to use the same node we used before, right? The greater than vector node here. And I'm going to compare this to this with an angle of 90, which is beautiful. This output is not going to be used to flip a vector, but rather set an angle for rotation, right? So we now have a rotation that is aligned to the Euler, right? But I want to rotate that vector around the curve direction, right? The tangent. So hit Shift A and rotate Euler. And let's set that back to axis angle, and the angle is going to be the tangent, but this angle is going to be different, right? You can see that if I set this angle to be 360 degrees, it's going to rotate everything into that, well, angle pretty much, right? So that is what we need to tweak with that value. So let's move this to the right, and let's just use this to find a switch. And it's not going to be geometry, but it's going to be a float, result to our input. And we want, if it is false, right? So if the direction is not negative, it's totally fine. We can keep the rotation at 0. But if it is, well, into the negative direction, we're going to rotate it by half a circle, pretty much, right? By half a full rotation. So 180 degrees, which is gonna be pi. This is in radians, which means we have to put that in as radians as well. So let's connect this into the angle. And you can see that everything rotated into the negative direction is now into the positive direction, which is exactly what we needed. Now we're going to add some noise to this level of branches as well. And we already have a noise setup for that first one that we can totally just reuse. Okay, so I want this to be part of that as well. And I'm just going to hold Shift and right mouse to just create a little dot here, just so we don't have 3 outputs of our group later. And just select everything, Ctrl G, and there we go. Now I'm going to connect my noise scale and the strength of this scaling node to 2 different outputs, of course, right? So the first one scale to the scale, and the second scale is actually the scale of this vector. So that is the strength. So let's call this the noise scale, and the second one noise strength. There we go, beautiful. And the output, let's call this noise vector, right? And let's exit this. Beautiful, and we can call this noise. Amazing. So we can just duplicate this, or we can just hit Shift A and find noise. Then we can get our group, and then we're gonna hit Shift A and find a resample curve, because we need to give some more detail, some more geometry to those lines. And then Shift A, set position, and that is going to be offset with our vector. So why is this not working? We need a realize instances just before that, so they know that they are individual curves and they can actually be treated as individual curve. Beautiful, so this is looking quite nice. Now everything is moving quite far away from our initial plane, which is not really something I want. So in the end, we can just find a set position node. There we go. Let's drag our plane back in, and let's connect this to a geometry proximity, and let's connect our position to the position. There we go. And that way, and let's set this to relative, by the way. That way, all of our curves are set to their plane, right? To the emitter object. That's not what I want. I want this to be controlled by the distance. So Shift A, mix color. I'm just gonna mix the vectors. Beautiful. And the vector B is gonna be just the position that it has currently, right? The current position of the points of the curves. And we can now change this. You can see, change this based on a factor. And I want that factor to be controlled by the distance, right? So let's crank this in. There we go. And now everything that is close to the surface will move a little bit closer as well. And the endpoints can actually just scatter what they do right now a little bit. They can move away from the surface slightly. Now, if we want to move this a bit closer to the surface, even those endpoints, we can just find, I guess, a math node. We can set this to multiply. And then we can just control how far everything is going to move towards the surface, right? Quite nice. Beautiful. Let's clean this up just a little bit, right? Which means I'm just going to move everything a little bit closer together. Beautiful. Right, so now I want those endpoints. Perhaps you don't want these to be sticking out as much. So how do we fix that? Well, we can actually use a trim curve. All right, so let's find a trim curve there. And I want this end trim to be defined on the distance to that emitter object once again. So let's drag that back in. There we go. Find another geometry proximity. Beautiful. And the distance is going to be used to trim our curve. Right, so that means that a distance of a larger distance need to be trimming away more of that curve. Which means that we actually have to reverse this direction with a map range node. Map range. And we can set this to be 1 to 0 and connect this to the endpoint there. You can already see it happening, and we can actually control that value with a little to max value, right? You can see that we can control how far those curves are trimmed away pretty much, and to minus as well. We can crank those a little bit closer together perhaps. You can see, beautiful, right? And that's a value we can control later as well. Now with our third layer of curves, we're set to add some leaves, right? Beautiful. So to do that, I'm gonna add my leaves to, we can add it to all the curves. So we're just going to hit Shift A, or just drag this out to an instance on points. Amazing. And let's just join this back up, join geometry, and let's connect these two. Beautiful. Now our instance, I'm just gonna use a placeholder, so add a little plane and call this leaf and press H to hide it. Right, so we don't really need that right now, but we want it to be connected here. So drag it in, connect it to the instance, set it to relative, and change the scale just to be a little bit lower. We're already spawning some of these beautiful leaf particles, right? So I want the rotation once again to be dependent on the curve. So drag it out to a curve tangent, and let's find an align Euler to vector once again. Set this to the vector, and let's see what value we want. X, Y, I think Y maybe. Let's unhide our leaf for a sec. And I'm just going to extrude this for a sec and scale it down and extrude it one more time, just so we have a little bit of a origin point. And in edit mode, I'm going to hit Shift S cursor to select it with this edge selected. And object mode, right mouse origin to 3D cursor, just so we know where the origin is at. Hide that. And now we can actually see what is happening. They're not really spawning on the right places, so I'm going to set this back to original. That usually fixes that. Beautiful. Right, so now we got the rotation along our curve. Now I want that, of course, to be more random again. So let's hit Shift A, align Euler to vector. Nope, a rotate Euler is what we need. There we go, connect that up. And the rotation axis angle is going to be tangent, and the angle is going to be a random value, right? From, let's set minus pi to pi, which is 2 pi in total, which is a full circle around our curve. Quite beautiful, amazing. So now we have our curve object. It's spawning nicely. I want the scale to be a bit random, so I'm going to set this to be a random value. A random value from a float, and setting that to a float just means that we're going to be scaling uniformly, which is nice. 0.05 to 0.15 perhaps. All right, that's too big, so let's just find Shift A, a math node, so we can just scale this a lot easier with a multiply. And set it to be 0.5, something like this. Looks quite decent, right? Beautiful, so that is already a nice Ivy setup, right? And it will stick to your servers quite nicely. Amazing. So the next thing is we're gonna be adding leaves in a sec, but let's just control the thickness of this curve first, which is something we do in this section right here, right? Before we add our instances. At this point, it is still a curve. So Shift A, curve to mesh, and the profile curve is going to be, you would think, a circle, but no, it's going to be a spiral. Reason why is because we can actually UV unwrap this properly and set the height to be 0, set the rotations to be 1, and start radius the same, resolution 3. Totally fine. Now, let's find a Shift A. It's looking bad now, but promise it's going to be better. Set this to be set curve radius, drag that in front, and set the radius to be a spline parameter. Alright, Shift A, find a math node. This is way too big. Set this to be multiply and like 0.05. Beautiful, so at least we can now see how this is looking. Let's find a float curve so we can actually swap this direction around with ease. And I'm gonna just drag this up a little bit as well. And I don't want the endpoints to be completely 0 in thickness, but a little bit thinner. There we go. And we can just set this to be a bit lower as well, 0.05 perhaps. That's looking better. Right, amazing. Quite easy to set up, quite nice to use as well. Right, so this is going to be our full curve to mesh setup. It's a little bit too thick still, 0.03, 0.002. All right, so there we go. And this is now our Ivy setup, right? So let's actually add a leaf. And to do that, I'm just going to add a texture to the plane we had before, the leaf here. I'm just going to hit shader editor, new, rendered view. Let's hit home to find our nodes here and select it and press Ctrl T. If that doesn't work, enable node wrangler. It is in edit preferences, add-ons, and just find node wrangler. And I'm going to open up a texture, and you will find that in the description as well. This one. Beautiful. And let's just set this to cycles for a second because I like it more. Amazing, and connect the alpha to the alpha. There we go. Then in the UV editor, let's just change the way this looks, right? Let's just U and unwrap this once again. I can rotate this and just make this match a bit more with the leaf, right? And let's scale everything a bit more in the X direction, unwrap it again. There we go. Now it matches a bit better. Something like that. And we can just move this a little bit, right? It doesn't matter that much. Amazing. Now let's make sure that our origin is exactly at this point. So Shift right mouse to move your 3D cursor, and then right mouse origin to 3D cursor. Beautiful. Now we can just hide this. Now in our Ivy, you can see it already applied there. Looking quite beautiful, right? Now that's looking quite decent. I think everything is set up quite nicely. Let's just go to our geometry node modifier. At the end, you may feel like your curves aren't really as well, as smooth as you liked. But we can just change that, right? At the split where it goes to the leaves and the other one goes to become a mesh, we can actually just find Shift A set spline type, and we can set this to be NURBS, right? And it's gonna smoothen that out quite beautifully. Right, now that may just be a little bit too much for you. So after that, you can always resample it once again to be a bit more blocky. For example, with 40 or 15, right? You can see that if we zoom in, we're getting those sections back. But at least we now have a little bit of a smoother look than without these two, right? If I mute these, you can see they're quite blocky. Unmute, they're quite round and nice, right? Beautiful. So then I want to set up, lastly, the density of my leaves is quite an important one. And that's controlled with how many points we have here, right? How many points we give to the instances. So Shift A, resample those curves. And now we can set a specific count. We can even divide this by length. So it's going to be giving a new point after a specific length, right? And we can just move this down a little bit, right? Beautiful. Now you have your own little IV generator. Amazing. And it works on whatever, right? Because we set it up to be working with normals. We can use it in any object. So if I extrude this up, it keeps working. Even if I move it to the front here, or if I add a loop cut here and move this to the front, right? It's going to be working. Make sure that your curve is actually going to be drawn on your surface though, right? So I'm going to delete my points. Make sure this is set at surface. And then if you draw your curve, it's beautifully on the surface. All right, amazing. Then just one more thing. I want to add a little bit of a fail safe to prevent the mesh from going inside of the emitter too much. And we already have got our sample somewhere, sample index. I want to use this same node setup. So we can just duplicate this all the way to the end, move it over. There we go. And this normal output is something we can use for that, right? So set position, there we go. And I want this to be a little bit of an offset in the normal direction. There we go. Vector math, and set this to scale. And now we can control how much of an offset it's going to get from that normal direction, right? I would recommend sticking to lower values. Perhaps 0.03 works fine. So it still sticks to the surface, but it's a little bit of a distance to add that failsafe. Maybe 0.02 works fine. And there we go, your own little scatterer. Beautiful. Now you can just add any parameters that you want to that group input and you'll be able to tweak them in the geonodes. For example, this one, I'm going to show a few. This one is going to be the first branching density, right? So we can crank this up and down to add more sub-branching or less. You can see, beautiful. Same thing, for example, for the length here. You're starting up with the curve line. We can actually drag this out to be a combined XYZ. That Z value is going to be the length of that first branching. So we can connect that there and find first branching length. And then we can control how long those second layer of curves are, right? Make them long, make them short, do whatever you feel like doing. Now, one more that I recommend doing is changing your input object to be a group input, right? This is now going to be an emitter object. Beautiful. And we can connect that to pretty much any group input we have that requires their emitter. There we go. Should be one more there. And then there should be one more somewhere more to the right there. That should be it. And this means that once we change our emitter object to something else, let's say we want a cube instead for the emitter object. We can now just, let's scale this down just a little bit. We can now just change our plane, or sorry, our IV object to be our cube, right? And it's going to be connecting to that cube, as you can see, right? And I can just start drawing more objects on that cube, and it's going to be connecting beautifully on that cube. All right. So that is as easy as it gets, I assume. It's quite an easy way to connect, control IV to different objects and have it very customizable and very real-time tweakable as well. All right, so thank you so much for watching. If you like this video, please leave a like, a comment, and subscribe. I'll enjoy any one of those. And then I'll see you in the next one. Cheers.